Welcome to video 2.10 on relative frequency. It's building on our skills yesterday that we learned from making those two-way frequency tables. So get your notes ready. You're going to have to write some tables, do some calculations, and answer some questions. First thing, very short vocabulary page. You just need what the definition of relative frequency is. And it's just the percent of responses compared to the whole. So let's say that out of 10 people, 6 responded that red was their favorite color. The relative frequency of that would be 0.6. You just divide the part by the whole. And if that came down to a percent, we know it would be 60%. So let's get into it. So when we calculate relative frequency, we leave our answer as a decimal and do not make it into a percentage. But you would do the process the same way as if you were finding a percent. So 92 people were asked how they got to work. Calculate the relative frequency for each of their responses. So my whole is 92. So all I have to do is say, okay, 35 used a car. I'm going to divide 35 by 92. And when we plug that into our calculator, we get 0.38. I'm going to round to the nearest hundredths place for these. For 42 people took public transit, we're going to take 42 the part. And remember, the whole is going to be the same for this entire survey because 92 people were surveyed. So 42 divided by 92, which is 0.46. Make sure you are rounding correctly. So in the calculator, this was 0.456. And I need to round to the nearest hundredth place. And because the 6 is larger than 5, I need to round this 5 up. If it was 0.5454, it would have stayed 0.5 because the 4 does not round it up because it's not greater than 5. Okay, for the next one, 8 rode a bicycle. We have 8 over 92. 8 divided by 92 is 0.0. I need to round again 9. 0.09. And for our last one, 7 people walked. 7 over 92, which is going to be, I need to round again, 0.08. Now the cool thing about relative frequency, once you've found all of them, they all should add up to a total of 1. So let's check that out. When I add 0.38 plus 0.46 plus 0.09 plus 0.08, it comes out to 1.01, which is very close to being 1. The reason that we have this 100th is probably because when we were rounding, we didn't round to the thousandths or the 10,000ths place. We weren't super accurate, so it was off by a little bit. But you want to know that if you do relative frequency correctly, it should come out to about 1 once you add all your relative frequencies together. So you're also going to see problems like this where you're going to have to fill out a table. So juniors and seniors were asked if they plan to attend college immediately after graduation, seek full-time employment, or choose some other option. A random sample of 100 students was selected from those who completed the survey. Scott started to calculate the relative frequencies to the nearest thousand. So we can see that some are already done for us, and we know how to find missing values in a two-way frequency table based on what we did yesterday. So I can see that my responses are actually here above the 100, the part. The 100 is the whole. So we have 25 and 60 in this column. Now 25 plus a number needs to add up to 60, which is going to be 35. So we have 35 out of 100, and we're rounded to the nearest thousandth. So my relative frequency here would be 0.350. Moving on to the next one, we are missing the juniors' responses for who plans to seek full-time employment after graduation. Well, we have 10 and we have 15, which means we're missing a 5 out of 100. So my relative frequency for that, when I divide 5 by 100, is going to be 0.05. 0. I'm adding the other 0 because we need to round to the nearest thousandths place. Now we have other options, and I see that I have 2 blanks in this row, so I can't calculate anything there yet, but I only have 1 blank here. So I know that I can find this missing piece. We have 45 as the total, 35 and 5 go into that, which means there's still 5 left over. So 5 out of 100 juniors are seeking other options, and the relative frequency for that is going to be 0.050. And now we can fill out our last 2 blank spaces. We have a 5 here. Oops, that was supposed to be this. 5 here and a 25 here. Well, what's missing from 25 is 20. 20 plus 5 is 25, so we have 20 out of 100. Seniors are seeking other options after graduations, 0.200. And now we can fill out the total by adding up each of my pieces here in this row. So we have 25 plus 10 plus 20 is 55. So we have 55 out of 100 seniors who responded, or 0.550. So we completed our calculations. Now, a website article indicated a vast majority of students from our school plan to attend college. Do you agree? So I'm looking at the plan to attend college and the total students who plan to attend college. While only 100 responded and 60 of the responders plan to attend college, I wouldn't say that's the vast majority, but that is a pretty big, it is the majority. So the majority of students plan to attend college. Majority of students plan to attend college. And you can be more detailed with your responses when you're doing your work in class tomorrow. Do you think that seniors and juniors differ in post-graduation options? Well, we can see that more juniors right now are planning to attend college, less are planning to seek full-time employment after high school, and even less than this 20 to 50 ratio right here are planning to seek other options. So there's definitely differences in the plans of seniors versus juniors. To your hot question, out of 98 freshmen at Quest, 79 go out to lunch and the rest stay in the cafeteria. What is the relative frequency of each of these lunch choices? So when you're answering your hot questions, I want you to put out to lunch, and then the relative frequency, and then cafeteria, and then the relative frequency of that. Make sure you put both those answers in there, and we'll work on this more tomorrow.